Hello, we're now starting our Module 17, which is quadratic functions. And here is the answers to the Are You Ready? So basically, you guys can all use symmetry, and you can all plug in an x, and you can solve for y. So our reading startup, the set of points where x in the domain of y and f and x is the graph of the function. So you can always replace an f of x with a y, and if you ever have ordered pairs. When a graph can be rotated or reflected and coincide in a coordinate plane with the original graph, it's said to have symmetry. And a relation in which every input is paired with exactly one output is a function. So number 1 and 2 for the understand vocabulary, the maximum or minimum value of a parabola is a vertex. So the maximum is like the highest point is the vertex, that'd be a maximum, and then if it goes down, like goes up, that would be your minimum, the lowest point. And then for number 2, the function of a number x, such as f of x equals 0, is a 0 of a function. So we're going to start with translating quadratic functions, which all this means is moving them up and down and left and right. So a quadratic function is a function that can be written as f of x equals ax squared plus bx plus c, and your a cannot be a 0. So all you have to do here to graph this is just plug in your -3 for x, so it'd be -3 squared, which is 9. -2 squared is 4. And that's 1, and that's going to be 9. So then when you do graph this, it's going to be f of x equals x squared, which is called your parent function. So you go to -3, 9, -2, 4, we'll skip it, 0, 0, 2, 4, and then 3, 9. So whenever you graph this, you just kind of want I didn't go down long enough, but you don't want to have straight lines. You want it to kind of curve like that. So for number 1a, what is the domain? Which, don't remember, domain is your x number, x values, so it's all real numbers, because your x values are all of these, and that's going to go on forever. So your y value is your range, so it's going to be all numbers greater than or equal to 0 here, because it's never going to go down this way. It's always going to go up with that graph. So vertical translation. So what we're talking about is a vertical translation of a parabola is a shift that goes up or down, and it doesn't change the shape. So I did include these in your notes, but basically this part here, that +2, tells me that the graph just goes up 2 places. It stays the exact same graph. It doesn't get wider or narrower. It's the same graph, just gets translated up 2 units. So if you look at the blue one, it goes from, the blue is the parent function, and then x squared plus 2, it just goes up 2 places. Same thing here for letter B. The original parent function is your f of x equals x squared. And see the -2, you're just going to take that same graph, move it down 2. So 0, 0 becomes 0, -2. That's it. It is fairly easy to do this on Desmos, and I would encourage using Desmos. So if you go to Desmos, you have your f of x equals x minus h squared plus k. So what we did is we just moved the k. So that's going to be this one. So do you see if we have a +2, it goes up 2. We'll go -3, goes down 3, but the graph does not change. It just goes up or down. So you can use Desmos whenever we're doing this. If you want to use it to graph, go for it. It's just like having a graphic calculator on your Chromebook. Alright, so if you look at number 4, it's going to be x squared plus 4. Instead of having a parabola at 0, 0, it's going to be right here. So it'll end up looking similar to that. It's easiest to do it with an XY chart. So that's the vertical, that's the up or down. Now the horizontal translation is going to be a shift in the parabola left or right with no change in the shape of the parabola. So this is your that's going to be your formula there. So f of x equals x minus h in parentheses squared. And that's going to go right or left. Remember that plus k after that is what goes up or down. So this is what's going to go left or right. So if h equals 0, it doesn't go anywhere. If h is greater than 0, so if it's like x minus 4, it's going to go 4 units to the right. And now if it's x plus 2, it's going to go 2 units to the left. So that's a little tricky. It is included in the notes that we have. So if you take a look here, we have g of x equals x minus 1 squared. So if it's minus 1, it's going to go to the right one place. So your blue is your parent function, and then your green is your new function. Do you see how it moved to the right one place? Now we have x plus 1. So since it's positive, it's going to the left 1. So it's just a little backwards whenever we're dealing with this. So if it's x plus 1, you go to the left 1 spot. If it would be x plus 7, we'd go to the left 7. All right, so graph each quadratic function. So if we just had a regular, and I'm not going to graph it perfectly because you would have to use your XY chart, you know, one of these where you plug in an x, so like 0, 1, 2. So you should always do like a -2, -1, 0, 1, and 2. That's usually what I use. So if you got -2 minus 2 is 4, or -4. -4 squared is 16. -1 minus 2, -3. -3 squared is 9. 0 minus 2 is -2, 4. 1 minus 2, -1 squared is 1. 2 minus 2 is 0. 0 squared. So we could graph those. But it's basically going to have the parent function. If you see the -2, that means it's going to go to the right 2. See the +3, that means it goes to the left 3. And that's about it. So now we have one more part, which is writing a quadratic function given a graph. So we're going to put everything together, and we're going to have or we can go back to Desmos and take a look. So the h, that's what we move. So if we make that a positive 1, so to be x minus 1 squared, see how it goes to the right, to the right, to the right. So once these become negative numbers, which would be like an x plus 1, that goes to the left. X plus 4, it goes 4 to the left. So we can also, instead of the 4, we can now move it up a couple. We'll go up 2. So remember, the k is what goes up and down, and the h is what goes left or right. Okay, so now writing a quadratic function given a graph. So we need the graph of a function f of x equals x minus h squared plus k is obtained from the graph. So if you look here, this one was moved, it went up 2 units. So we're going to have our +2. Now it went to the right 1, 2, 3 units. So remember, when it goes to the right, it's going to be the minus x minus 3 squared plus 2 equals f of x. So f of x equals x minus 3 squared plus 2. So you can, for step 1, it says notice the location of the vertex. The parent function has a vertex at 0, 0. This function has a vertex at 3, 2. So that's where going to the right 3 is going to be your minus 3 here. And going up 2 is going to be the 2 there. So determine the values of h and k for the function. So that's all you're going to have to do there. So this one, so compare the parabola. So we'll do a g of x equals x something squared plus something. So this part here is what goes up and down. Now if you notice, it's going down 5 units. So that's a minus 5. Now it went to the left. Got to look at that part right there. So it went to the left 4 units. So if it's going to the left, it's going to be a plus 4, since it's kind of opposite. So that'd be g of x equals x plus 4 squared plus negative 5. And if you want to check, you could just plug in numbers, say negative 4. Negative 4 plus 4 is 0. 0 squared. And then minus 5 goes down 5. If you have any questions, please reach out to me and I can help you out any way that I can. Awesome. Thanks.